Hi Trigoner, so we're going to take notes on Chapter 1, Section 6. Our objectives are to be able to solve an equation of a quadratic type using substitution and to be able to solve equations with radicals. So as a little warm-up right now, let's go ahead and take a look at that first problem. Notice there are actually 4 problems that I'd like you to try. So go ahead and pause the video and try 1 through 4, and then we'll meet you back here in just a minute. All right, so if I ask you to evaluate the square root of 81, that's the principal square root, so you would just say 9. But if I said x squared equals 81 and you solve, notice there are 2 values, because if you say 9 squared, that equals 81, but the opposite of 9 squared is also 81. So that's why, again, if you have an expression, square root of 81, you have one answer, 9, principal square root. But if you have an equation, you're saying, what are all the values of x that make this a true statement? There are 2 values. Also, 2 other things that people get mixed up on. If I have AB quantity squared, that's a squared b squared. But if I have a sum, if I have a binomial, if I have a plus b quantity squared, notice that's a squared plus 2ab plus b squared. Okay, so now that we did a little warm-up, let's go ahead and start solving. So if you're going to solve, the first thing you want to do, solve a quadratic, you want to have a 0 on one side of the equal sign. I should say of the equation. And then we're going to try and factor. Okay, if you can't factor, your backup plan would be the quadratic formula. You could also maybe graph these. We'll talk about that also. So let's go ahead and subtract 4. And you'll notice this actually is not a quadratic equation. This is degree 4. So one thing that you could do is you could say, let's let m squared equal a. Okay, so then you have a squared plus 3a minus 4. So go ahead and pause the video. How would you factor a squared plus 3a minus 4? Okay, so hopefully you said the quantity a minus 1 times the quantity a plus 4. So if a is 1 is a, and a is negative 4, notice that was m squared. So if m squared is 1, and if m squared is negative 4, notice that m is plus or minus 1. And again, if m squared equals negative 4, that means that m is plus or minus 2i. So we have 4 answers. So we call this like a quadratic type of an equation, and we use substitution. So go ahead and pause the video and try problem number 6. All right, so did you say that b to the 4th minus b squared minus 56 is 0? And we let b squared equal a. So now we could say that a minus 8 times the quantity a plus 7 is equal to 0. So if a equals 8 or a equals negative 7, but we have to recall that a was really b squared. So b is plus or minus 2 root 2 or plus or minus I root 7. Okay, let's go ahead and take a look at number 7. This time we're going to do something similar. Again, we're following our steps. We want to have 0 on one side of the equation. But go ahead and pause the video and think, what would you call a this time? We are going to make a substitution. What do you think we should call a? Pause the video and think about it. So this time, we're going to let a be k squared minus 1. So if we have 4a squared plus 11a minus 3, we can factor that. So go ahead and pause the video and think about how would you factor 4a squared plus 11 minus a minus 3. Because again, if we let a be k squared minus 1, this is going to be a little easier for us to factor. All right, so if we have the quantity 4a minus 1 times the quantity a plus 3, now we know that a is 1/4 or negative 3. But again, a was k squared minus 1. So now we know that k squared, if we add 1 to both sides, let's think of 1 as 4/4. So if we add 4/4, we have 5/4. And over here we'll add 1. So k is plus or minus I root 2. Or over here, we get plus or minus root 5 over 2. Why don't you pause the video and try number 8. Again, very similar. This time, we're going to let a be z squared plus 5z. So pause the video and see if you can factor and solve. Let's see how far you got. So did you do a squared plus 3a minus 4 equals 0. And we could factor the quantity a minus 1 times the quantity a plus 4. But remember, a was z squared plus 5z. So now we have a quadratic. So we need to get 0 on one side of the equation and try and factor. Remember, if you can't factor, you'll have to use the quadratic formula. So go ahead and pause the video and give it a try. All right, so over here, let's see, for this one, we were able to factor. So we could say z plus 4 times the quantity z plus 1, and we have two answers, z equals -1 and -4. But over here, we could not factor, so we had to use the quadratic formula. We end up with -5 plus or minus root 29 over 2. Okay, so nice job on that one. Let's go ahead and move down here to the radicals. Now remember, our other objective was to be able to solve equations with radicals. So let's just review a little bit. If we're trying to find the domain, do you remember at domain restrictions we looked in denominators and under radicals? So we know that x plus 3 has to be greater than or equal to 0. So we know that x has to be greater than or equal to -3. Or over here, that would be our domain. Over here, we know that 5 minus 4x is greater than or equal to 0. So if we could subtract 5, if we divide by 4, don't forget to flip your arrow, you have x less than or equal to 5/4. So when you think about domain, it also probably would have helped. Like, for example, number 9, we know that a radical x moved left 3. Again, our parent function moved left 3, looks something like this. So of course our domain is greater than or equal to -3. So what I want to do for this next one, number 11, oh, that was supposed to be a y, sorry. Let's go ahead and think about how you would graph, right, if this is a left 2 from our parent function. Oh wait, actually I didn't mean that to be an x, sorry. So we're trying to solve this equation for x. So again, we have y equals radical x plus 2. And then if we wanted to graph y equals x. So go ahead and graph and try and think about what type of, how you would solve that graphically. So if you take a look at your calculator and you type in radical x plus 2 and x, I'm just going to do a zoom for this time. So if you take a look at the graph, we want to know where those two functions are equal. So I want to know what x value, okay, because we're saying solve for x, will those two equations have the same y value. So let's take a look. If we did calculate, intersect, and we want to find that intersection. Okay. So that would be at 2, 2. So that means that when x is 2, these two graphs have the same y value. So we know the answer is x equals 2. But let's go ahead and solve this algebraically. If we square both sides of the equation, and now we're going to go ahead and have 0 on one side of the equal sign, and if we factor, notice that we get 2 answers. Okay, but we already graphed it, and we know that there is only one answer. This answer is actually extraneous. So what happened was when you squared both sides of the equation, you created that extraneous solution. So we end up with just one answer. And again, when you solve graphically, you will see, graphically will not show extraneous solutions, but algebraically might. So what we're going to do right now is go ahead and try 12, 13, and 14, and realizing after this example up here that if you solve this algebraically, you are going to have to check all of your answers for extraneous solutions. So go ahead and pause the video and try number 12 and 13. Okay, so for number 12, a lot of us probably stopped right here and said, well, the square root of a number is positive. So we probably knew that was not going to have any real solutions. But let's say you still squared both sides of the equation anyway, and you got 1, and then you went to check it, you went back to your original problem, and you realized that's not true. So there are actually no solutions for this problem. And over here, if you square both sides of the equation, because again, you would like to solve for x, so let's go ahead and do that. If we square both sides of the equation, on the right side of the equation, we have x minus 3. On the left side, x squared minus 5x plus 25. So If we subtract x and add 3, you end up with x squared minus 11x plus 28 equals 0. So go ahead and pause the video and see if you can factor and solve. There you go. So you could factor this. The only problem is before you say you're done, you do need to make sure that you don't have any extraneous solutions. So you would have to check. Now, it ends up that 4 is not going to work and 7 is, but let me just show you how you would check that. So you would go back to your original problem and you would say, let's let x be 7. So everywhere you see an x, you replace it with 7, and you want to know, is that equal to the square root of 7 minus 3? So 2 equals radical 4, so sure, 2 equals 2, so the 7 worked. But this time we're going to check x equals 4. So you go to your original problem, and you want to know, is 4 minus 5 equal to the radical 4 minus 3? Negative 1 is not equal to 1, so you would say 4 is not a solution. Okay, let's go ahead and try 12. If we add radical 3x plus 10, or sorry, 3x minus 10, now when we square both sides of the equation, we could go ahead and subtract the x from both sides and add 10. So x is 12. The only thing is you would have to check your answer. So pause the video and check your answer and see if 12 is extraneous or if it is a solution. And when you check your answer, you realize that 12 is a solution. All right, 2 more examples. If you take a look at 15, this one looks a little tricky because you have a constant over here and you have radicals. So what I would suggest, if you have more than one radical, is look at the uglier one by itself first. So 4x plus 9, that one's uglier. So we're going to isolate the radical 4x plus 9, and then we're going to square both sides of the equation. So here we go. If we square both sides of the equation, on the right side we get 4x plus 9. On the left side we get 2 root 2x squared plus 2 times 2 root 2x plus 2 root 2x plus 1. So let's see, that's 2 squared is 4 times 2x plus 4 of these root 2x's plus 1 equals 4x plus 9. So now we have another radical. Let's isolate the radical 2x and square again. Go ahead and pause the video and give it a try. All right, so now as long as you were able to divide by 4 without creating yucky fractions, I would say go ahead and divide everything by 4 and then square both sides. So go ahead and pause the video and finish up. So there are so many ways. After we go ahead and use the quadratic formula for this one, right, you end up with 0 equals x squared minus 6x plus 4. When you use the quadratic formula, you have 2 answers. The problem is you have to check both of those. Now, this is an ugly decimal, so I will show you how probably the easiest way to do it on the calculator. If you grab your calculator right now and go to y equals and type in the left side of the equation and in y1 and the right side of the equation in y2, now what you might want to do is go to table set, which is above window. Because remember, if you're going to use the table, you have to set the table before you can use it. And if you cursor down to independent and change it to ask, notice if I go to the table now, which is above graph, I can type in anything I want for x. So again, your 2 solutions were 3 plus root 5 and 3 minus root 5. So if I go ahead, I'm going to type that right in, 3 plus root 5. Oops. Clear that out. 3 plus root 5 and 3 minus root 5. Now if you look at the table, notice that for y1 and y2, for 3 plus root 5, 7.47 is not equal to 5.47, but for the second one that we checked, which was 3 minus root 5, 3.47 is equal to 3.47. So that might be the quickest way to do it. So 3 plus root 5 was not a solution. Okay, so for this last problem, something very similar. You're going to square both sides. So go ahead and pause the video and give it a try and come back and we'll check our answers. So you square both sides and now we have to isolate. So we had 2 radicals. So now we have to isolate the root x plus 5. Now notice that you can't divide everything by 2 without making ugly fractions. Go ahead and do that. All right, so after you square, you realize you have x plus 5 equals x squared minus 2x plus 1. So go ahead, you have a quadratic. Get 0 on one side and factor. But again, you have to check all of your solutions whenever you create an irreversible step like squaring both sides. So 4 did not work. Negative 1 was your only answer. Great job, everybody.